Jai Hind everyone, I am Pankaj Kumar and today's lecture is about the Henderson-hasselbalch equation and the isoelectronic point in the amino acids. So dear friends, in last videos we studied about the amino acid types of amino acid and the nomenclature, one letter nomenclature of the amino acid and how the amino acid will help in the stability of the proteins and their special features we talking about. It was little long video, but I will try to make this video short. If it will be little going long, you just put it into the 1.5x or any according to your understanding ability. You can put your speeds of this video. So today's lecture is going to be very important. Why? In today's lecture, we will understand the amino acid as we seen the polar charge, polar uncharged, polar uncharged amino acid, so non-polar amino acid. So this all things we studied in the last video. So because of that we find the amino acid will have the S3 N plus and CO minus. So this is the common groups in the in every amino acid. So if there is a positive one, there is a positive negative one, so it will become a net zero. But because of some change in the pH, because of change in pH, amino acid will get any charge. Amino acid can behave as either acid, it can behave either as a acid or it can behave either as a base. So before moving to the amino acid base isoelectronic point and all, we'll try to understand what is acid and what is base. So acid is nothing, it is a compound or molecule which have a tendency to donate proton. Proton means H plus. So amino acid have a tendency to donate a proton, and if we'll see the base, so base a molecule which can accept a proton. So this is all about the base. Now we'll see the base and acid. So we can take one example. Suppose this is a one compound, it is reacting and it is giving you the Ha. Ha is breaking down into Ha H plus A minus. So Ha and H plus or A minus will be give you the like a conjugate acid and conjugate base. So what we said, the proton donor will be what? A acid. So who is giving the proton? So proton is given by this Ha only, but it is getting one negative charge. If it will give one proton, it means what? It will contain one extra negative charge which is here. So it will act as a conjugate base. It will called as a conjugate base, and this will called as a conjugate acid. Conjugate acid. It will called as a conjugate acid. So for the equilibrium constant, if you see, the equilibrium constant will be equal to the H plus and A minus concentration, like product concentration divided by reactant concentration. So this is what? This is your dissociation constant as well. This will called as a dissociation constant. Dissociation constant. Now, if I'll ask what is the pH? So what will say? The pH is nothing. It is the negative log of H plus. Negative log of H plus is what? It is a pH only. Negative log of H plus is what? Is the pH. First important thing you understood, negative log of H plus is what? pH. Now if I will ask you what is pKa? Why we need to study this all things? Because you will understand how the reaction will take place in terms of the biological lab or the chemical labs. If you have to make any x number of pH, how much mole of the x compound you will take to put in a solution, so that solution will become x number of pH. Okay, so that's why we need to understand these all things. So pK is what? pK is the negative log of Ka. What it is? Negative log of Ka. But what do you mean by the pK? pK, it, pK is just the tendency of a molecule to give up a proton with that the tendency decrease the 10 folds as the pKa increase by 1 unit. So I will write this what I written in for myself. So negative log of Ka. So you can write it like log 1 by Ka also you can write, and this is what pKa. If I will write the definition, so definition will be like this. Tendency of a group to give up a proton, that tendency decreases tenfold as the pKa increases by 1 unit. So first tendency to give up a proton is called as a pKa. So if one pKa is increasing like from 1 to it become 2. So what does it mean? The tendency 10 times of the tendency will decrease to give a proton, to release one proton. So this is the pKa. So what now from this can you make any relation between the pKa and any H plus? Can you make a relationship with it? So as you know, the Ka just now we seen the dissociation constant is equal to what? H plus A minus divided by Ha. This we restudied. Now if you'll see H plus we have to find. Okay, I'm putting this H plus one side and I'm passing all these units, this unit and this unit in the left side. So what I will get? The Ka into Ha divided by A minus. So what is this? A minus. This will become your conjugate base, and this is will be your acid. So now you put the log on both side. If I'll put the log in this both side, this side also and this side, then it will become what? It will become pH equal to, okay, anything I'm doing wrong? Am I doing anything wrong? Let me check. No, everything is correct only. Okay, I have to just put minus log. I have to put just minus log. This is the so minus log of the pH H plus. So log minus log we put. So minus log of H plus will be the pH and minus log K will come here. And minus log of K is what? Minus pKa you can write. You can write minus log of K is what? pKa. Whole unit was in the minus. Now you just reciprocal it. So it will become log base by acid. Base by acid. You can write it as base by acid. So this is your most important formula for Henderson-Hasselbalch equation. This is your Henderson-Hasselbalch equation. How you'll use this formula we'll see, and we'll try to solve this formula's question on based on this also. Before that, I will show you some diagrams and we'll understand the pKa value and all these things. We'll understand the isoelectronic points and remaining things. So as you can see, the amino acid can behave as a acid as well as base. So that type of molecule, usually amino acid, which will behave as a acid as well as the base, uh, that called as a amphoteric. There will be another term like amphipathic for the lipids, which will act as a polar as well as non-polar. So this is the very fascinating thing that amino acid can behave like a protein, sorry, like a acid as well as the base, depends upon the nature of the and the function of the protein as well. So from this behavior, we found a new term. This is called the isoelectronic point. So there will be, while transition from acid to base and base to acid, there will be somewhere one point in which it will behave as a neutral. Definitely, you know, and you do agree with me, I think. So are you agree with me? Yes or no? Yes. Fine. So you can say the glycine. We took the picture from the lineage, and you can follow that book. This is a good book. Uh, the glycine, you can see this is the glycine. Okay, so here there is a this is the glycine. Wait, now this stage and this stage, you find it here. Here there is a no, there is only one positive charge. There is only one positive charge here. Okay, fine. So this will act as a what? This will act as a base. Sorry, acid. It will act as a what? It will act as a acid. Got it? Sorry. This NH3 plus means it can able to it have a capacity ability to attract one electron. So it cannot act as a acid. It will behave as a base. So at this point, the pK. Okay, fine. This will act as a acid only. This will act as a what? Acid. So it have a positive charge, and this will give the acidic behavior. And now the pK1 value is how much? 2.34. Once it will get, once it will donate, it will donate, it have a ability to donate a proton. So it once it will donate, it will get a negative charge here, and as well as it is having also one negative charge it have, as well as it have a positive charge. So one negative, one positive will balance, and it will give you the zero net charge. Fine, here only one positive charge, here one. Now if it will donate one more proton from here, it will donate one more proton as a H plus, then what will be there? An H2 will get. So net charge will be only negative, and it will get the -1 charge. So now the question is that at what pH it will have a neutral charge or net zero charge. Here it have a negative charge. So what is the pH for this? What is the pH for this condition? So you know the pH for the pK base as well as the acid. So what you have to do for finding the isoelectronic point, you have to take pK1 plus pK2 and just divide with the 2. So you will get the same value. You can try with this question. So if you will try, suppose pK1 is how much? Not suppose, it is written there only 2.34. And what is pK2 value? It is 9.6 only, and divided by 2. What you will get the isoelectronic point? It will be around 5.9 only. It will be around 5.9. Got it? So this is the pH at which the isoelectronic point will be 0. Okay. So isoelectronic point or isoelectronic pH both are same, as already we seen in this definition. So hope so you understood. So in this case of the glycine, there is the functional group is a hydrogen, so we don't worry about it. The functional group is a hydrogen, so there is no big issue. But what if there will be any acidic or a basic functional group in like this in glutamate and histidine? So if there is a acidic and basic functional group, so what you have to do, you will get that 3 pKa values. What you will get? You will get the 3 pKa values. So in this diagram, you say you see this. So if you see the glutamic acid, in this glutamic acid, at this stage it have a zero charge. At this stage it have a zero charge. So in this it become as a acidic because it have only one positive charge in this. Got it? One ammonia. Now if it will protonate, sorry, if it will, this OH will be protonate. Sorry, if OH will be deprotonated, then it will become CO minus. So once it will become a CO minus, the net charge will be how much? Here one positive charge, here one negative charge. It will be net will be 0. Now come to this point. In this COH will also able to deprotonate. Once it will deprotonate, one proton will be released. It will get one more extra negative charge. So it will get -1. Now another way, is there any other place which can deprotonate? Yes, this H plus also can deprotonate. So once this H plus will deprotonate, it will get the NH2, and finally you will get the -2. So in the this case it have a 3 pKa, one because of the ammonia, okay, one because of the ammonia, one because of the carboxylic acid, and one because of the R group. This is the R group only. So because of this R group, it is getting one negative charge. This is the R group. Okay, this one is the R group, and because of this, it is getting a negative charge, and one because of the carboxylic acid, which is normal in every amino acid. So because of this, it will getting the 3 pKa values. So in this case, how we will find the pi value? Which values you have to take? So as you know, the glutamate is acidic value, acidic amino acid. So first you have to take the pKr value. Okay, so just you take the pKr value, and you can take the pK1 or pK2. So it depends upon the acid acidic amino acid or basic amino acid. Divided by 2 you will get the pi value. So how you will decide the acidic or basic pk pk value you have to take. So glutamic acid is a acidic in nature, so it is a acid, so you will take this acidic value. Okay, now in case of the histidine, this is also giving a acidic value and this is also giving a basic value. So which value you have to take? Now in this case histidine is a basic. Histidine is a basic amino acid, and if it is a basic amino acid, you have to take this pK2 and pKr. So in any case, pKr will be there, and the remaining amino acid, like remaining value, will be depends upon the nature of the amino acid. So it will give you the pi value. So you can check here. The 4.2 pKr is what? Here 4.25 plus 2.19 divided by 2, it will give you the around 3.22. So hopes you understood this thing. This is the easy and simple concept. Now we'll see some questions related to this, and then we'll wind this topic. So this is the definition. You can remember it for the three pK values, either pKr, pK1, pK2. So pK1 you can indicate as a pKa also for acidic, pKb for pK2 for basic, and pKr because of the functional group. So amino acid with ionizable R group have three possible ionization steps, thus they have a 3 pKa value. And how you can find the pi? The pKr plus pK acidic or pK basic, it depends upon the which type of amino acid it is. If it is amino acid acidic like a glutamate, then you will take the pKa acid. pK1 value like 2.19 is a acidic value. Now if it is a histidine, then instead of taking acidic value 1.8, you have to take value of 9.17 because it is a basic amino acid. Let's go for some questions which will brings your concept more stronger. So find the isoelectric point of amino acid where pKa's are 2.2 pKa are 3 and pKb is 9. A and B is the indicating the acid and base. Here A acid and here B basic. So P for Pi, what you will write? The pKa is 3 plus 9 divided by 2. It will be 11 by 2. So it will be around 5.5. It will be around 5.5. So this is your acidic Pi. Now the question is that choose the correct statement for isoelectronic point in respect of glycine. So what you have to do, you just pause this video and you can solve first, and then you can check for the your answer. So glycine, you have to find the statement related to the isoelectronic point in respect to the glycine. So first it is saying the glycine isoelectronic point is a basic. So this cell itself, it is a wrong. Just now we studied here in this diagram the isoelectronic point is 5.97. It means it is not a basic, it is a acidic. Now second point, it is second statement, it is saying glutamate have a higher uh, isoelectronic point than the glycine. So glutamate is acidic, so it should not have the higher, it should be lower. This is wrong. Arginine have a higher isoelectronic point than glycine. So arginine is a basic and it can be have the higher isoelectronic point than the glycine. Okay. Valine have the same isoelectronic point the glycine. This is a false statement. So correct answer will be C. Let's see for the another question. Choose the amino acid below with the lowest isoelectronic point. You just pause the video and you check the answer for this. So lowest amino acid isoelectronic point will be with the higher acidic one. Okay. Lowest amino acid with the most acidic skeleton. Okay. So most acidic means what? You will see here all have the NH plus, NH plus, NH plus. This is the common in all. So most acidic means what? More carboxylic acid or more compound which will have the more capability to protonate. Sorry, deprotonate. It will give the proton in the medium. So definitely they give the 2H plus because it having 1 minus and it have 1 minus. So 2 minus net is minus 2. It means they give 2H plus rather than other are giving only 1. So this will be the correct answer for the more higher acidic. Calculate, if I will ask in this same question, if I will ask you, choose the amino acid below with the highest isoelectronic point. So what will be your answer? You just tell me in your comment box. I will reply there only. So let's see the another question. Calculate the pH of, this is the question based on the Henderson-Hasselbalch equation. So in this Henderson-Hasselbalch equation, what you have to see, uh, the formulas which we read, you can go back forward and you revise if you forget in the video. So calculate the pH of the solution prepared by the mixing 5 ml of 0.5 molar NaOH and 20 ml of 0.5 molar benzoic solution. So the dissociation constant is written here 6.46 into 10 power minus 5. So what are the given we have? So we have a given concentration for NaOH. We have a 0.45 molar its concentration, and it's calculate the pH of solution prepared by the mixing of this much 5 ml. So this is 5 ml. Now, now we have to convert it into the mole. If we have to convert in mole or molar substance, okay. So what you have to do? We have to convert this mole per liter. So this is a molar. Then we will convert it into the mole per liter. Then this have to be converted into the ml have to be converted into liter, and this is already in the mole per liter. So this will be same as a 0.505. I said 0.5 molar, 0.5 molar. So here it is a 5 ml. So 5 ml have to be converted into liter. So it will be how much? 0.005 liter. So you multiply this both, multiply this both, and you will get 0.005 into molar is how much? 0.5, and you will get the answer. Here you will get 0.005. 0.00250. This will be your answer. So our question is not completed. So let me make some more. So same we have to do for the another molecule which is our benzoic acid. So benzoic acid will be how much? 20 ml benzoic acid in 0.5 molar benzoic solution. So again for benzoic acid it is 20 molar, 20 ml. So how much liter it will be? 0.02 liter. Okay, 0.02 liter into 0.5 ml. Yes or no? 0.5 molar. So it will be around how much? It will be around. So it will be around how much? 0.01. So benzoic acid is our acid, and then NaOH is our base. So mark it here, it is a base, and this is your acid. Now we have to find the pKa, but you know you don't have the pKa value, you have only Ka. How much Ka is there? K is written 6.46. This is our Ka. So 6.46 into 10 power minus 5. 6.46 into 10 power minus 5. So if it is written like this, then what you have to do? You have to convert into the pKa. And how you can convert into the pKa? Just minus log of Ka will be the pKa. So minus log, you just put, you can use your calculator also, as we are biology student. So we can use the calculator, and most of the examination also calculator will be available for you. So minus log, and Ka value is 6.46 into 10 power minus 5. If you will calculate by pen and paper also, or by calculator, you will get the same value, and it will be 4.19. It will be around 4.19. Now we are ready with the everything. This is our pKa, and now we'll write the formula which you remember. The pH is equal to pKa plus log base by acid. Now put the value, get the answer. pKa value is how much? 4.19 plus log 0. Base is 0.025. 0.0025. Am I writing correct? Correct only. Now divided by 0.01. Divided by 0.01. So how much it will be? It will be 0.25. So log 0.25 will equal to how much? Let me calculate in the calculator once. So it is showing minus 6. Point minus 6. Okay. So pH is equal to 4.19. If you will solve this, you'll get 0.602 something. So this will be equal to 9, and then yeah, 5 3.59 is your pH. 3.59 is your pH, and this will be your answer. Hope so you are following me. If you are having any doubt, you can contact me. You can comment me if you need any type of solutions. Now the last question, which is very important for your laboratories also, if you're doing any job. So this is question the very important for either you're preparing for the any exam, or you are working in any lab as an assistant, or you are working as a project assistant, anything. So this is the important questions which you have to try to solve, because this is a practical questions which we have to make in our lab. So the question is that how many grams of the NH4Cl need to be added to 1.5 liter of 0.5 molar ammonia in order to make the buffer solution with pH 8.58. So like basic dissociation constant is given. So we have the most important pH is already given. We need 8.58. So what we need? We need to find the how much gram of NH4Cl we have to need. We have to find, and molar solution of the ammonia is already given. And now we'll find the mole of the ammonia, and then we'll find the NH4Cl. Got it? So let's begin. The pKb, if you have to find, so how you'll find the pKb? Again, minus log of pKa, pKb. So minus log of 1.77 into 10 power minus 5. You can calculate. So it is coming, pKb is coming around 4.7. So you got this. You have the pH. Now put the formula, get the answer. So pH is equal to, again, pKa plus log base by acid. Now in this time you have to find the acid. NH4Cl concentration you have to find. Now pH is 8.58. pKa is how much? Just now we find 4.7. And log base. So base value is already there. It is plus, sorry. Thanks for correction. You can tell me the correction if there will be like that, plus minus sign corrections. So pKa base is, what is the base? Ammonia is will be the base. Now concentration of the ammonia is how much? So concentration of the ammonia NH3 will be equal to 1.5 liter into 0. I think it is 4 molar, huh? 0.4 molar. So how much it will be? 0.6 will come. 0.6 divided by acid. So NH4Cl, you can write NH4Cl. So now what you have to do? You So here we have to do one more work. Instead of this small thing, we have to add some more thing here. Actually, we don't need a pKb. We need what? We need the pKa. Okay. So we find the pKb, even it is fine. But how we'll find the pKa? So for finding the pKa, we have one formula. You note it down here. I'm going to draw this concentration. You can write it here. This will be the useful point only. So I'm making it into the box. I'm giving this one box. So we need a pKw, pK of water, and it will be equal to pKa. It will be equal to pKa into pKb. So pK of water will be at 25 degrees Celsius. It will be around 14 only. So you can write it like this: 1 into 10 power minus 14. And now pK will be equal to divided by 1.77 into 10 power minus 5. So finally you will get the pKa equal to 5.64 into 10 power minus 10. Now you will use this value for finding the uh, pKa. Sorry, you just removed this. This is the dissociation constant of the water and acid and base. It's not pKa. Sorry. So this is a dissociation constant you found. So after finding the dissociation constant, what you'll do? Minus log of the K. Minus log of K. Now everybody can calculate in your mobile itself or in your brain. So minus log of K is equal to how much? Minus log 5.64 into 10 power minus 10. How much it will be? For me, it is coming around 9.2. Is it coming for same? It is coming for you as well. So this will be your pKa. Now this is the then you found the pKa. You found the concentration here. You found the ammonium concentration. You found the pH. So now we'll put this same things. So pH will be around 8.58 equal to pK is now 9.2 plus log 0.6 by acid. Now it will be little tough, maybe. So 8.58 minus 2, 9.2. So minus 9.2 plus 8.58. It will be how much? It will be 2, 6, and 7. It will be 0.62. So now it is a 0.62 equal to log 0.6 by acid. This will be in the minus sign only. सो अब क्या करना है, यहाँ पे आके तो गाड़ी रुक जा रही है ना कि यार अब कैसे कन्वर्जन करें। तो यहाँ पे क्या होता है कि जब लॉग यहाँ पे राइट हैंड साइड यहाँ जाएगा तो एक्सपोनेंशियल में कन्वर्ट हो जाएगा। सो ई पावर माइनस 0.62 आप ले लेना। सो ई पावर माइनस 0.62 का जो भी वैल्यू आप कैलकुलेटर में यूज करके बताओगे, चेक करोगे, वही आएगा 0.6 बाय हमारा एसिड के बराबर, NH4Cl के बराबर। सो हम क्या है, एसिड क्या है हमारा, NH4Cl लिख दे रहा हूँ, NH4Cl के बराबर। सो अब यहाँ पे क्या करना है, देखो, बस इधर से इधर करना है, बस कुछ नहीं। NH4Cl इक्वल टू क्या होगा, इसका वैल्यू कितना आया था, इसका वैल्यू 0.62 का वैल्यू था 0.51 इक्वल टू 0.51। सो 0.51 को इस तरफ ले गए आप तो 0.6 डिवाइडेड बाय 0.51 क्या आएगा, 0.6 divided by 0.51. Actually, I will suggest key you have to use mostly up to 3 digits numbers. Okay, so then only it will be going to be helpful. You will not get any trouble in that. So 0.6 divided by 0.51 will be around 1.176. 1.176. So this is your solution. Now this will be your solution for this question. So it will be unit is also very important. Unit will be how much it will be, the mole. Okay, we are all taking the mole. So this is your answer. If you want to counter check, you put these values, NH4 cell, this you put, and this you take already, you know, 0.6, and you solve like this. pH is equal to pKa plus log 0.6 divided by 1.17. If it will become around 8.58, then this will be correct. And please tell me in the comment it is coming or not. We'll see in the next video the remaining topic. In next video we'll see the protein structure like beta chain, alpha chain, and what will be the graph in that. So thanks, we'll keep watching with my videos. We'll meet in the next video. Jai Hind. So keep watching my videos. We'll meet in the next video. If you have any doubt, any queries, you can tell me. And the more questions if you want to solve, the more questions are there in the description box, and you can go and check into the Biology app all by clicking the description link. So thanks for watching me that videos. Jai Hind. We'll meet in the next video.